So hello! This does look like a strange arrangement, doesn't it? But I've decided the best way to help you with the maths today is talk you through the PowerPoint. I did start drawing 3D shapes, but you've seen me drawing. They look like giant squiggles. So, I'm going to go through the slides. You won't be able to see me because it'll be very confusing, but you can listen to my lovely dulcet tones. And I'm going to talk you through today's learning, and then we will see how you get on. So, crew, let's start on this first question. Is that good? Is that good? Yeah. Right. So, work with a partner, that might have to be mum, or you can have a go yourself, to name three properties of faces, the number of faces, the vertices and the edges of each shape. Recap. Face is the big smooth surfaces. Vertices is the 3D word for corners, and edges is where two faces meet. So we'll just have a look together. Let's look at the first shape, the cylinder. Now, as you can tell from the cylinder, it's got one face on the bottom, one face on the top, and then that big face there. So it's got three faces. Edges, it's got one there, and then one there. So that's two edges, and there's no vertices. If you aren't sure on this, get a can out of the cupboard. You've got cans, tins in your house. That can help you. Let's look now at the square-based pyramid. Well, we know it's got a square at its bottom, and if you think about a square, here's a nice coaster I've just found. A square has four sides, so it's going to need four triangles, so four faces to make the pyramid. One triangle coming from there, one from there, one from there, and one from there. So that would be five faces, the square on the bottom and the four triangles. Then edges, well, if we've got 1, 2, 3, 4 edges from the squares on the bottom. Then 1, 2, 3, 4 edges where the triangles meet. So that's 8 edges. And if we're looking for vertices, we've got the vertex on the top. And then we've got the 1, 2, 3, 4 where the squares. So 5 vertices. I'm going to let you guys have a go at the rest of them. But that is how we would name the faces, vertices and edges. If you can find these in your houses, consider using 3D models to help you. Okay, now let's go through a few questions. Which of the 2D shapes is not a face of this hexagonal prism? So we're looking at a hexagonal prism and the shapes that make up its faces. So, on the top, we've got a hexagon. It's a hexagonal prism. So I'm pretty sure that there's a hexagon in it. That makes sense, doesn't it? So we'll rule out hexagon. So has it got rectangles or parallelogram faces? Well, if we look right at the front here, that's a rectangle. So the shape that doesn't make a face of the hexagonal prism must be the parallelogram. There it is. Okay, next question. List which 2D shapes and how many of each you would need to make a net of this 3D shape. Okay. So, this is a pentagonal prism. So, we've got to name the shapes that make the 2D shapes that make it and how many. So, on the top, we've got a pentagon. So, on the bottom, we're also going to have a pentagon. So, it's two pentagons. Okay, then the question is, we know we can see one rectangle. How many rectangles will make up the rest of the shape? Well, if we think that there's 5 sides to a pentagon, we're going to need 1, 2, 3, 4, 5 rectangles coming off of the edges. So it will be 2 pentagons, one at either end, and then 5 rectangles. 2 pentagons, 5 rectangles. Okay. Now, this is where it gets tricky. And if you can print, I would recommend you print and then cut them out. Because this is always, we had this last year, either you see it or you don't. I don't see it. It takes me a lot of thinking. Right then, this net would make a hexagonal-based pyramid. True or false? Well, we can actually do some maths here. A hexagon has how many sides, Alfie? Yes, 6. So if we're having a hexagonal pyramid, we're going to need 6 triangles. If we've got 6 sides, we need 6 triangles. That makes sense, doesn't it? So let's count here. We've got 1 triangle there, 2, 3, 4, 5. It's not going to work. We have got a 6th triangle missing. It wouldn't go all the way round. It would leave that one without a face. So I'm going to say false. Do you agree with me? Do you agree with me, Alice? Yeah, you should do, because I think we are correct. It would need 1 more isosceles triangle. Super job. Okay, now, this is where my brain starts to collapse. But this one isn't too bad. Which of these nets would make a cylinder? Which would not? Okay, a cylinder is a tin of beans. Or any tin can, anything like that. So, if we think about it, if we folded those two circles in and then wrapped that around it, that would make a tube, wouldn't it? So I think A would make one. The same as... Yeah, sorry gang, I told you, I'm useless, I just can't visualise it. Same as C, we could fold them in and then wrap the paper around it. It would work, wouldn't it? B, however, because it's got a piece there that does not make a full rectangle, it wouldn't. The can wouldn't close properly. Super job. But as I said, if you can draw these or cut them out and make them, I recommend it. Right then. Now, in the reasoning today, guys, we have some questions that I think you'll get easily and some that are trickier. Let's have a quick look at them. Riley, Ola and Tim have made nets for a pentagonal-based pyramid. Check which nets would work and explain any mistakes which have been made. So, are you looking at it? I think it's fairly obvious. I think Tim's on the money because his isosceles triangles are all the same size, so they should fold up and close. Ola, I think, has had a bit of a day of it because I think she's got a bit wonky here. She's got different size triangles. They're pointing different directions. If you folded them in, it certainly wouldn't close fully. And Riley has done a fairly good job, but at the last minute he's gone all slapdash, hasn't he? Look, he's like, oh, I've done 4 good ones. No, that would not close properly because it's not a proper isosceles triangle. Should we see? Yeah, Riley's net would not work. One of the triangles is wider than the others. They need to be identical. Tim's would work, and Ola's are all different sizes. They need to be identical. So for a prism to work, a prism or a pyramid or any kind of 3D shape to work, in certain cases, they need to be identical, especially pyramids. Okay, Marty has not been able to finish his net for an octagonal prism. Complete the net for him. So, you could print this or draw it. So straight away, I hope you're with me. We're going to need 4 more rectangles coming off of that octagon. However, that will only build the case. We need the roof. So what shape do we need to make the roof, Sam? Yes, for the roof of our octagonal prism, we would need another octagon. And that octagon could come off of any of our rectangles. Let's see what they put. Yeah. But that octagon could come off of any of the rectangles. It could be, as long as it was equally put. So super. Right, then let's look at the next one. Charlotte is thinking about 3D shapes. Good for Charlotte. I will always need 2 identical squares to make a truncated square-based pyramid. Now, gang, I'm going to leave you to do this one. I do know, before you think I had to look up truncated pyramid, but it works. Now, I think once you look up truncated pyramid, so Google it's our friend, it will make sense to you. But I want you, when you looked at a truncated pyramid, I want you to say to me, would 2 identical squares be needed? Have a think. Right, gang, that should finish us for today. It's been 9 minutes, so I'm going to leave you to it, or I'll be uploading forever. But I think you can get on with that well, and we have finished our work on shape and space. Whew. On to new learning next week. Bye-bye.